Okay, so thank you so much, everybody, for joining. Good afternoon and good morning to all the attendees. My name is Abdul Basit. I work for a company called Pester Business. With me here is my colleague, Mr. Fabian. He is one of our most expert guys when it comes to the industrial connectivity with lots of experience in the industry. The main topic of today's webinar is to help you understand the differences between REST API, MQTT, and OPC UA technology, and which protocols you should use when you are designing your architecture. Okay. And for example, during this presentation, if you have any questions, you can always put in chat and we are going to respond. Thank you so much. Let's start. Okay, so in this presentation, I'm going to give you a little bit introduction about our company, giving you a holistic view, sharing with you the information about multiple technologies, REST API technology, MQTT protocol, OPC UA technology, giving you a little bit introduction about the different use cases, and also sharing with you our recommendation based on our experience and the key differences which we believe are the most unique differences between each protocol. And at the end, we are also going to share the knowledge that how you can link your OT with your IT. Of course, keeping in aspect the cyber security and, for example, multiple other things which you should consider while designing your architecture. And at the end, we are going to give you a little bit introduction about our own connectivity platform, which is very powerful, and we are going to show you the demo of our platform at the end. So thank you so much for joining. Let's start. So as a Bester Business, it's a company which has multiple offices. We have 4 different offices, one office in Spain, one office in France, one office in Costa Rica, and we have an office in the US as well. Inside Bester Business, we have multiple divisions, okay? Inside Bester Business, we have Industrial Connectivity Division, and inside Industrial Connectivity Division, we have 2 software offerings. We are official distributors for Metricon for many European countries, and also most of the Latin American region is covered by us. Then we have our own connectivity platform, which is called vNode. The second division which we have is called our dedicated SCADA division, in which we have a solution called AtVoice, which is basically pure web-based HTML5 SCADA. Then the third division is the specialized industrial training division, in which we provide trainings on multiple topics, for example, OPC technology, IoT for industry, cybersecurity, 3 days on site. And also, if you prefer, we can do it online. So based on your requirement, we can choose whichever option you prefer. Okay. So this is basically the holistic view of the company. So let's jump into the discussion. So first of all, what is a REST API protocol? So REST is basically an architecture.
Abdul, there is a request for you to speak slower so people not so into English can get you.
Okay, sorry.
No problem.
Okay, so thank you, Fabian. So yeah, what is REST API protocol? So REST API is basically an architectural style which is used in web services development that allows systems to communicate over internet using HTTP or HTTPS method. In REST, you have a REST API client and you have REST API server. So basically, REST API client is asking a request and REST API server is responding to all those requests. So it's a request response service that operates over HTTP or HTTPS. The typical format which we use in REST APIs is JSON or XML for the data exchange. Each request is basically mapped to a unique to a resource identified by a unique URI. URI means uniform resource identifier path on the server. So when the server receives the request, it handles the request based on the service specified on the path. Okay. So normally, what are the typical requests which a client is asking? So the typical requests are get, post, put, or delete to create, retrieve data, or for example, to delete data. The server processes these requests and the server processes all these requests, and then it responds to the request. And once this communication is over, there is no further connection between a client and a server. So this is how the REST API protocol or the REST API technology works. So what are the typical use cases when we are using REST? So for example, if you want to collect the data, for example, from your PLCs, your DCSs, your OPC servers, OPC UA, OPC TA, or all, for example, devices which speaks Modbus protocol, and then you want to collect all these data and you want to push the data to an ERP system. Normally, in most of the use cases, this ERP system is SAP. And SAP can be, for example, REST API client and REST API server. So based on the configuration, we can choose our connectivity platform, which is called vNode. It will collect the data. It will help you to collect the data from all these different technologies, Modbus, OPC UA, or all these protocols, and then it will push the data to a REST API client, in which vNode can be REST API client, or it can also be a REST API server. But based on whatever, based on the application on top, we can decide which technology we are going to use in vNode. So this is the typical use case when it comes to the REST APIs. The second communication technology is called MQTT. Okay, so MQTT is machine-to-machine protocol for IoT or for telemetry transport. It's an event-driven protocol. So, for example, when there is a change or when there is no direct communication between a publisher and a subscriber. In MQTT, you have MQTT publisher, then you have a broker, and then you have an MQTT subscriber. The publisher is when there is a change, or when there is a new value, the publisher pushes the data to a broker, and when broker receives this value, it pushes the new value to the subscriber. There is no direct communication between your publisher and your subscriber. Everything is going through your broker. So we use MQTT when we want to detach the systems, when we want to create no direct communication between your publisher and subscriber. It's an event-driven protocol where there is no continuous transmission of data. So you have your data, and then you have a new value, and your publisher is collecting all the value, and then it pushes the data to your broker. So this is how normally the MQTT works. Okay. So to quickly summarize the discussion which we were having, MQTT is basically a push services. It's a push service that works as a publisher and a subscriber, that works on a publisher and subscriber model. Each message is filtered based on topics that belongs to a path under the broker. So each client, or for example, each publisher must connect to a central server, or you can call it, which is called broker. So this central server is called broker. You have publisher on one side and subscriber on the other side. Okay. And you can connect as many as publisher to the same broker, and in the same manner, you can have as many as subscriber to the same broker. When a client pushes up, for example, when a publisher pushes a message to a broker topic, other subscribers can also read this topic, okay? Can also subscribe to all this topic. So MQTT works like this. There is no direct communication, and it can be used when you want to detach your systems and you don't want to allow, for example, direct communication with your publisher and subscriber, okay? So this is how the MQTT works. The typical use cases in case of MQTT is, for example, you want to collect the data from your devices, and then you want to push the data on top to cloud platforms. For example, you want to push the data to Amazon Web Services, you want to push the data to Microsoft Azure or Google Cloud, or whichever cloud platform you are using. So in such use cases, MQTT is most used technology. Okay. The third technology which is also one of the most important and one of the most widely accepted, is OPC UA. So OPC UA is basically vendor independent communication technology, and it's mostly very much powerful for the industrial automation applications. It's also based on the client and server methodology. So for example, you have an OPC UA client and OPC UA server. OPC UA client is asking, and OPC UA server is responding to all those requests. But in contrast to REST APIs, there is a continuous communication between client and server. So the technology is vendor independent, with which also integrates security mechanism. So OPC UA is very much flexible and it's independent, making it very much ideal for the industry 4.0 communication. Okay. So what OPC UA can offer us? Number one, it offers agnostic connectivity to any data source. For example, you want to collect the data from your devices, from your PLCs, your DCS, so we can use OPC UA. Okay, it's an event-based. It can be an event-based delivery, or it can also gives the data in multiple formats. For example, you can have real-time data, you can have historical data, and it also incorporates alarms and methods as well. The connections between OPC UA client and OPC UA server, it's basically automatic. So if there is a disconnection, it gets automatically reconnected. And also in OPC UA you have multiple, for example, you have multiple multiple security levels. So you have a transport layer, then you have a session layer, and then you have an application layer. So these are the multiple options which OPC UA can offer. Okay. So to summarize that in which types of projects and which types of use cases we have with OPC UA. So for example, if you're working in a project in which you want to collect the data from multiple devices, for example, you have Siemens, you are working with Siemens PLCs, you are working with ABB PLCs, and then you want to collect the data, you push the data to a central location, and inside that central location, you want to develop your centralized monitoring system. You want to develop your centralized EMS system, or you want to develop your centralized SCADA. So in these types of projects, we are going to use OPC UA, which is basically the recommended protocol. Okay. So what are the recommendations when you are using different technologies? For example, OPC UA, we use OPC UA. It's solely based on our recommendations and our experience in the industry for more than 20 years. So we recommend to use OPC UA, for example, in industrial automation and control systems requiring security and scalability, number one. Number two, for example, if you want to have real-time monitoring and you want to have control in structural hierarchies, for example, in your factories, in your process plants, we recommend to use OPC UA. Why? Because it has a strong support for secure structured communication between devices and systems, and it has a continuous connection between client and server. So, for example, the client is always connected to the server, and if there is any value, it's directly transported to the client. Okay, so it's not based on the request. It's ideal for Industry 4.0 projects. The second technology is MQTT. So when we recommend to use an MQTT, for example, for IoT applications where the need is to have a lightweight and bandwidth effective communication. Okay. When also the processing power of the devices is not very high. For example, if you want to collect the data from remote sensors or actuators, you can use MQTT. MQTT also uses publisher subscriber module for event-based data exchange. There is no direct communication between your publisher and subscriber. Everything is going through broker, and it's basically an event-driven data exchange. So if there is a new event, the publisher will publish and subscriber can read the data. Okay, if there is no continuous communication, it's very much highly efficient for low bandwidth, high latency, and unreliable networks. So, and also perfect for IoT and edge devices. So when you are in these kind of projects, the recommendation is to use MQTT. So when we use REST APIs are mostly adopted and mostly used in web applications or systems where the requirement is to integrate over HTTP or HTTPS. Also, the systems that require data exchange on demand rather than continuous communication. So for example, the client has a request, the server is responding, and that's it. The client again has a demand, the server is responding, and that's it. So these kind of communications we recommend to use REST APIs. Why? Because it's also very simple, flexible, and widely supported for system integration. And number second, which is very important, it's very excellent. The communication protocol is very excellent for broader communications. For example, you want to use web services, mobile applications, or you want to use, for example, an application, a centralized application. So all these types of applications, where the recommendation is to use REST API technology. Okay. Okay, so what are the key differences step by step? These are the key differences which we observe are very important, but of course there are lots of other differences, but according to our experiences, these are the most useful differences between all these three technologies. Okay, so in case of, for example, standard formats in REST API, there is no standardized format. The payload agreement should be between client and server, and also in case of MQTT, there is no standardized format. Okay. The payload should be agreed between a publisher and a subscriber. But in case of OPC UA, you have a very structured data, which can be used as a standardized format. How is the connection? The connection each time, for example, the client has a request. In case of REST API, the client has a request and the server is responding, and that's it. There is no continuous communication. In case of OPC UA and MQTT, you have continuous communication. And that's why when it comes to the technology of OPC UA and MQTT, you can also have store and forward. It's part of the technology. So for example, if there is a loss of communication, the OPC UA server or can store the data. For example, with our connectivity platform, vNode, we can store the data when we are using OPC UA technology. And once the communication is back, we can push the data with the original timestamp to the client on top consuming the data. Okay, so this is the second difference when it comes to the communication. The third difference, the format in case of REST and MQTT is based on message. You have a message with a body and with everything, but in case of OPC UA, you have OPC tags. So this is the reason you require parsing when you received a message using REST API or MQTT technology. But in case of OPC UA, as there is no, the message does not need any kind of parsing. So because it's based on tags, so that's why you don't need any parsing when it comes to the OPC UA technology. Parsing means you want to decode the message which you are receiving from the client, from the server, or in case of MQTT, you are receiving from the publisher. So the level 3 security which REST API offers is based on user or path, or in case of OPC, you have user or tags. In case of MQTT, you have user or topic. So what is the additional benefit when it comes to the security? So for example, you have a topic, and inside that topic, you have multiple data. You have multiple information. So you can have the security based on topics. But in case of OPC UA, you can have it based on tags. For example, a tag for temperature, a tag for example, a tag for your pressure. So you can have this security, which is in case of MQTT, you are sending the topic, and all the information is being it can be seen by the subscriber. So the firewall configuration in case of REST APIs, you need to open from client to server. You need to open at least one port to establish this communication. In case of OPC UA, normally you also need to open from client to server. You have an OPC client and OPC server, and if there is a firewall in between, you need to open from client to server. But in case of, for example, if you are using Metricon OPC data broker, it allows also to have OPC UA reverse connectivity. So as reverse connectivity is also incorporated in the technology, but most of the time it's not being used. But in case of Metricon OPC data broker, you can have reverse connectivity feature. And of course, in case of MQTT, you need to open from publisher to the broker. So it already incorporates the reverse connectivity feature. So you don't have to set any incoming, you don't need to open any incoming port in your control firewall when you are using MQTT protocol. So these are the key differences and the key recommendations from our side. Okay. So let's just have this discussion that how you can link your OT and IT. And first of all, what is difference between OT and IT? Okay, so operational technology is basically considered, for example, all your plant floor devices, for example, devices, PLCs, your DCSs, which are basically controlling the processes. So everything lies in the OT. So for example, devices from, you have a Siemens PLC, you have a device from Rockwell Automation, you have an OPC UA server, OPC DA server, which is reading from a DCS, or for example, you have devices, you have inverters, which, for example, speaks Modbus protocol. The most of the use OT protocols are OPC, for example, Modbus, DNP3, IC protocols, or for example, SNMP, BACnet. So these are most of the times OT protocols. So what are these IT protocols? IT protocols, when it comes, for example, you want to push the data to a centralized database, you want to send the data to an ERP system, you want to send the data to a cloud platform. So these are all the applications which are in the IT words, and the normal communication protocols in IT are REST APIs. For example, if you want to push to an ERP system, MQTT, if you want to push the data to cloud platform, or for example, if you have an SQL database. So these are all the applications which are basically consuming the data. So to successfully incorporate and to successfully link your OT with IT, with your IT applications, you need a IoT gateway, which basically converts from one communication protocols to other communication protocol. Based on our experience, the main purpose of while you guys are choosing your IoT, your gateway, should not be just to translate from one protocol to another protocol. Our recommendation is also go with the solution which is basically an holistic solution, which provides you the end-to-end solution, not only just like protocol communication and that's it, but it should also incorporate cyber security features. It should also incorporate, for example, if you want to perform some kind of calculations, it should also incorporate not only sending the data to, for example, a specific technology, but it should have the adaptability features. So this is our recommendation, and based on our experience, we have developed our own connectivity platform, which is called vNode, which basically incorporates all these features. So what is vNode? vNode is a software. It's basically a software, the software which can be installed in, for example, any embedded computers. If you want to install in Windows, if you want to install in Linux, if you want to install in virtual environment, if you want to use for example, if you want to use containers, so you can install in any operating system, in any hardware. The software has multiple functionalities. For example, if it can collect the data, for example, from multiple OT protocols, and it can push the data to multiple network levels, and across each network level, which is very important, across each network level, you don't need to open any incoming port in your firewall. It already incorporates the reverse connectivity feature. So for example, you want to design an architecture in which you have multiple network levels. And at each network level, you want to perform some specific tasks. For example, at network level number 1, you want to collect the data from your devices. And network level number 2, you want to push to a SCADA. Then you want to have another network level in which you want to perform some kind of data calculations, data aggregations, and then you want to send the data to an MES system. You have an SQL database, or if you're using an historian. And then on top, for example, if you have a DMC, then apart from then you have level number 4, in which, for example, you have a business or corporate or IT network, and then you want to push the data, for example, to cloud platform, for example, to a business intelligence software, or if you are using, for example, SAP. The beauty of vNode is that, for example, as you guys know, that things in OT, they move very slow. So for example, if you're working with a PLC, that PLC will stay there for the next 20 years. But things in IT, they move very fast. Today you have a cloud platform, tomorrow you want to use another cloud platform, then you want to use a business intelligence software, which is more powerful. So the things in IT move very fast. But the beauty of vNode is that once at network level number 1, you have everything inside vNode. On top, you can decide, for example, today you are using one platform, but tomorrow you want to use another technology. So the modular approach of vNode is that, for example, you want to send the data to a cloud, for example, no problem. MQTT client, you send the data to cloud. But tomorrow you want to send the data to a device, to an application which supports REST API. No problem. We already have a module which can push the data to a REST API client. Okay. So this way you can improve your architecture. So our recommendation is always, not while you are choosing your IoT gateway, not only use it as a protocol converter, but it should also serve as a standardized communication tool, not for your current need, but also for the future need. So these are all the requirements which are basically already incorporated inside vNode. Okay, so just to clarify, guys, this is just a demo, and this is just like an example which I'm going to show you. The demo will be shown by my colleague, Mr. Fabian. So in this demo, for example, if you have a project, if you are working, for example, in solar farm, in wind farms, or for example, in distributed assets, or if you are working in a plant floor in which you have multiple control networks and multiple IT networks. So we recommend to install remote vNodes. Just to clarify, guys, remote and central is same piece of software. There is no difference between remote and central. The software is exactly the same. Okay. So we installed remote vNodes. We install vNodes and call them remotes in multiple locations. And for example, on one side, you want to collect the data from, for example, from power meters, which supports the TLMS protocol, or devices which supports, for example, Modbus. And also you want to collect the data from any OPC DA server, from Metricon or any other vendor. For example, on right side, you want to collect the data from Siemens PLC. So you need to configure 4 data collection modules. And to deliver the data to, for example, to SCADA, to an ERP system or cloud platform, you need to configure 3 modules, which are called OPC UA client. And then you have to push the data to SCADA, REST API client or server to push the data to SAP. And then you have MQTT client to push the data to cloud platform. Okay, so this is basically a very, very, very easy architecture. So for example, to know that how we can have vNode installed in all this, in all of your projects. And now I hand over this presentation to Mr. Fabian. He's going to give you a quick demo, and then at the end, we are going to have question answers. So if you have any questions, please write me in chat. Over to you, Fabian. Thank you.
Excellent. Thank you so much, Abdul. Very, very good explanation. Let me share my screen so we can, here, let me share my screen. Is this one, share, and I can follow from here. There you go. All right, can you see my screen? I think you do. All right, so I was thinking this week with Abdul about how to perform here a demo that is easy to, of course, easy to show, easy to understand, and it's just taking between 10 and 15 minutes. And so we were thinking about, okay, let's use vNode and how to interact using these three technologies, right? MQTT, OPC UA, REST. So vNode can be a REST client. So if we put here a REST server, we can use vNode to collect data from using REST. vNode is also a subscriber, an MQTT subscriber. So if you have an MQTT publisher using a broker like Mosquito, for example, or any other, so we can use vNode to collect data from any publisher. Or we can also use vNode to collect data from an OPC UA server using the OPC UA client inside vNode. So this way, vNode would be collecting data, would be a client for all these technologies. But then we said, okay, but what on the other side? What are on the destinations? So we can also, vNode can also be a REST server. So apart from being a REST client, can also be a REST server. So if you have a REST client, that's typically SAP or any other client, REST client application, so we can also deliver data, all the data that we collected from these three technologies or many others. Actually, right now in vNode, we have around 50 different modules to move different technologies around, so we can supply REST data to a REST client. Also, we can publish MQTT data to a broker and then get it in a subscriber, like the one you can have in Amazon Web Services or data hub in Azure and so on. Also, we can supply OPC UA data. So because vNode can collect all this data and publish as an OPC UA server. So vNode can be an OPC UA server to send data to one or multiple OPC UA clients. So we said, okay, how to show all this? We don't have much time. We need to do this demo quickly. So we said, okay, let's do this. We are going to simulate vNode collecting data from different multiple data sources, going through a firewall with no open incoming ports, moving data from OT to IT. Okay, so and on the other side, we're going to have another vNode, okay, collecting data, getting data in real time from this vNode in OT across the firewall. In IT, we're going to have REST client, an MQTT subscriber, and an OPC UA client, of course, in a simulated way. Okay, I'm going to use testing tools for this. So because of course I don't want to make this so long, so we're going to focus in this side, in the IT side. So we're going to I'm going to show the configuration in this vNode in the IT side. I'm going to show the configuration for the REST server, and we're going to be using Postman as a REST client to collect data from vNode. So we're going to be collecting Modbus tags. So I have another vNode collecting, reading Modbus devices. So we're pushing data in vNode in real time, and then we're going to serve REST data to Postman. We're going to publish MQTT using Mosquito to MQTT-FX. It's just an MQTT client. And we're also going to be sending data to UA Expert. It's a UA, OPC UA testing client. All right. So we're going to be showing these three technologies. vNode is going to be a REST server, an MQTT publisher, and an OPC UA server. And we're going to be moving data to these three clients using three technologies at the same time. All right. So let me show you here. Let me put my computer where I have this running. Is going to be here. Can you see the virtual machine? Yes. Okay. So this is a virtual machine. In this virtual machine, I do have a vNode here. So I log in. Okay, so I have this already configured. So I'm going to show the configuration. So if I go to diagnostics and the modules I'm using, so I'm using the module MQTT client, OPC UA server, and the REST API server. Okay, the web UI is the user interface because we are using here a web browser for configuration. So all this is using demo licenses, so there is no need for real licenses. You can run a vNode with demo licenses as long as you need. And then in the configuration, in the configuration, well, first, I have a link. In this link, I am getting data from another vNode. We can see it here. So I'm getting 3 tags, Modbus, three tags, and I can see in real time, I can see a folder called Modbus, and I have my 3 tags coming from the other computer, right? And they're actually changing from here. If I want, I can write something back to my controller. So just to show, oh, this is read and write. All these tags are read and write. So I'm going to use REST first. So here I have my REST server. Okay, so this is really, really easy to configure, needs very little configuration. So I can give data, I can be a REST server using HTTP or HTTPS. Okay, I have a port. I can configure my network interface, and then if I choose HTTPS, so there are all these set of configurations for certificate and encryption. All right, so that's it. Actually, that's everything to configure, nothing else. So there is, of course, there is a user manual for this, showing all the different methods and different functions for the in order to interact with this OPC, with this REST server. So here I have Postman, and in Postman, let me open Postman. So Postman is here is a REST client. You probably know it. And here I have a collection showing all the different methods I have inside the REST server in vNode. So very easy. I don't need to write one by one. So you can select from here what you want to do. Want to play with the tags, read, write, historical data, real-time data. You can filter and so on. Alarms, backups, system links, modules, licenses. So there are many ways to interact with the software, right? So here I'm going to read the tags. This is my IP, this is my port, and this is the command in order to read data from a folder called Modbus, and then the asterisk means everything inside. Okay, I'm using authorization, my default authorization, the username is admin vNode, and actually that's everything I need. If I just send the message, we are getting an answer, okay? The answer is a JSON showing, if you see, the value, the quality, and the timestamp in a POC format, okay, for tag number 2, for tag number 3, for tag number 1, and so on and so on. Okay, so I am getting REST data coming from vNode. So we are getting exactly this data. We are getting this data in JSON format in a REST client. Okay, so if I request again, so it's going to give me a different value. Okay, I believe every 2 seconds data is changing. So every time I make the request, we're going to get a new value. I can also write data. So right now, for example, if I go to tag, which one I have here, tag number 1. Here, tag number 1, I have, what do I have here? Tag number 1, I have this value. So I'm going to write, so this is the command to write, and I'm going to send this JSON, okay, saying, hey, I want to write tag 1 with the value of 55. Of course, I can write many tags at the same time. So if I send this, I should get a 200 quality. And if we go now to see the values, so this should be, there it goes. So I wrote the 55, and now it's increasing one by one. Right? So again, send this. If I go here, we are writing 55. So the REST client there is requesting a change to vNode. vNode is sending the command to the PLC and is writing this value in the PLC. Right? There's a chain of commands from the REST client to vNode. Actually, this vNode is sending the command to the other vNode in OT. The other vNode in OT is writing the value to the, in this case, a Modbus PLC. Right. Excellent. So next, we're going to be showing MQTT. So in MQTT, if I go here to config, I have module MQTT. MQTT has more things to configure. So I can create connections. to brokers. So I have a connection to Mosquito that I have running in localhost, okay, here in this computer. So I have multiple options here. So the IP of my broker, the port, and so on. And then in this connection, I can have publishers and subscribers. So to this same broker, I can publish data and I can subscribe data and I can publish in many different ways and many different messages at the same time, in different frequencies, for example, and I can also subscribe in many different ways from this same connection from the same broker. And of course, I can make as many connections to many brokers as I need. Okay, there is no limitations. In this case, I created a publisher. Okay, this publisher is going to send events to the broker every 5 seconds. Okay, and I'm going to be sending this using JSON format in something called, let's say, extended. These are different data structures. Okay, it's going to be the date format is going to be ISO, and I have a tag filter saying, okay, what do I want to send? So what I want to send everything. Everything I have in this vNode, I want to send it out. Or of course, I can from here I can send, well, and now I have only one folder, but if I have many folders, I can select what is the content and what data I want to send. So right now I want to send everything, which is this, all right? So this is working already. So if I go to my client application, it's called MQTT FX here. So if I go here, let's see if it opens. What is happening with this? No? What is happening? Okay, let me close it. All right. No. No. MQTT is not answering to me. I don't know why. Let's kill MQTT. There we go, and start MQTT again. This is a testing client application to connect with any broker and test how to collect data, right? There are many MQTT client applications. This is just one client application that is free, so it's easy to install it and use it, right? Is this working or is not? There you go. All right, finally. Okay, so I'm going to connect here to Mosquito, all right? And I want to subscribe, okay? And I want to scan topics. So if everything goes well, here I have my Modbus. Actually, I don't know if I show here, but at my topic is Modbus. So I'm sending all these messages under the topic Modbus. Of course, you can create as many agents as you need with different topics. So in this case, we are using Modbus as topic. So I'm going to subscribe to Modbus, and I'm sending messages every 5 seconds. There we go. Okay, so every 5 seconds, I'm sending this message, okay? So I can, something very, very interesting in vNode, in this module, MQTT client, is that we can create our own format. So right now, I am sending this format with a T, a V, a Q, and a timestamp. So we can have the name of the tag, the value, the quality, and the timestamp. As you can see, we're receiving messages every 5 seconds here. But this is 100% to customize. So I can customize the format, the message, as I want, as I need, because usually the client or cloud applications, they're expecting something very specific. So we can configure the format to be whatever we want. So in vNode, we have 2 standard formats. And then if we don't like these 2 standard formats, this actually is called the extended. We can create our own is here. So we can create our own option, our own format, okay? So, well, this is what I wanted to show. So every 5 seconds, we are sending a new message with all this information. So as you can see here, for each tag, we have multiple JSON objects. So we have tag 1 here, and then we have tag 1 here. As you can see, we have a timestamp here and a different timestamp here. So as you can see, in each message, we are sending several values for tag 1, because we're sending data every 5 seconds, but in 5 seconds, we have like maybe 3 different values. So what vNode is doing is collecting all the changes during these 5 seconds, and in every message we are sending, because we configure this to send events, so we are sending all the events that happen between deliveries, between data deliveries. Okay, so that's why in each message I have tag 1 with a timestamp and a value and timestamp, and then here I have again tag 1 with the next value and a timestamp, and so on and so on and so on. All right, excellent. All right, so we have 216, 218, and so on. So we can see here how we have multiple tags and multiple values from the same tag in the same message every 5 seconds, right? So the third, let me show you very easily here how I can change the format, because this is something that I get many questions about. So if I go, instead of here, I go to custom, I have a ready to go JavaScript script where we here, this JavaScript, this is ready to use, but this is showing that we are sending this T, V, Q, and timestamp. So if I just go with this, so we are going to be getting this format in here. Let's wait for 5 seconds. So we're in the package. There you go. Here. Okay. So we are getting this format T, V, Q, and TS. But of course, as I selected custom here, so I can add whatever I want in the message. So for example, I'm going to add here, I'm going to add to the JSON like user, for example, and it's going to be Fabian. So if I go like this, of course, there you go. All right. So just to show that we can change the content of the messages as needed, right? So wait for 5 seconds until this is sending the next message. There we go. So as you can see here, we just changed the message and we created a custom message to the delivery to the cloud, okay? Or to the broker, and from the broker to the client to subscribe. Okay, excellent. So moving on, let's go to the next, which is the OPC UA. So in vNode, we have another module called OPC UA server. So we have our network interface. This is my local IP. This OPC server is listening this port. Of course, we can make this secure. We can have certificates. We can allow or not anonymous users. We can have multiple endpoints. So this is really, this is very easy to configure. And actually, it's very powerful. So this is already listening. And I have here my UA expert. I don't know if you know this client. Again, it's an OPC UA client for testing. So I'm going to connect to vNode. I'm going to say, okay, I want to connect to this IP, 192.168.3.189, and the port is 3005, which is my local host. In this case, of course, you can connect to any number of OPC servers. And on the other side, vNode as a server can be connected with as many needed clients, all right? There is no limit. So I have to select an endpoint and a user. Just to make it easy, I'm going to connect with no security. Of course, this supports all kinds of securities, like this one. Actually, this is the most secure endpoint. Okay, and then all right, and okay. And here I can make a connection. And that's it. So here I have Modbus here, and I have my 3 tags. So I can select my 3 tags, and I can see my tags changing in the OPC UA client. So again, this OPC UA client is connected to vNode. vNode is connected. vNode in IT is connected to vNode in OT. vNode in OT is connected to our Modbus device. So again, from here, I can change. I can send a command. So this client is sending a writing command to vNode. vNode is sending to the other vNode in OT. The other vNode in OT is sending the command to the PLC, and then we have to read the new value. That's why it takes like 1 or 2 seconds to see the new value, because one thing is writing, so the write is immediate, but then takes maybe 1 second to read back what we just wrote. All right. Okay, then what else? Here on the server, I believe we only have, well, actually, we don't have tags locally. We can see the same tags here. So, well, I believe this is mainly what I wanted to show today. Abdul, what do you think? We are okay? Anything else you want me to show?
Yes, just please show that how we can restart the modules. I mean, after 2
Yes, all
hours,
right.
yes, please,
Good.
because
Very easy, very quick. So going to config modules, here is where you can instantiate the modules in vNode. So in vNode, we have today around 50 different modules. Here in module, you put a name, and then in this name, under this name, you can select any of the modules available in vNode today. So here we have OPC DA client or OPC UA client and OPC UA server, and so on and so on, to speak from SNMP or from Siemens PLCs and so on and so on. So once you create your modules, let me go to the other menu. Here in diagnostics and the menu modules, everything you create is going to be here. Of course, I don't have a license, a production license, because I'm just using this for demos. So when you create a module, automatically goes to demo license. So here, this runs for 2 hours. After 2 hours, this is going to turn red, just like this. Nothing is lost. So the configuration, everything is still here. Okay, so but this is just, this module is not moving data anymore. So after 2 hours, if you want to keep playing with the software, you just go here, press start, and you have another 2 hours, and like this, as many times as you need. No limit of tags of times you can restart the modules. So you can make all the configuration, test everything with demo licenses. You need to ask anything to anyone. All right. Good. Anything else, Abdul?
yes, I have some questions, Fabian, that we are receiving. So number
All
one
right.
question is that it's basically related to the communication between publisher, so in subscriber and the broker. So the question is that MQTT indeed continuous connection between broker and subscriber. Can you please share a bit
Well,
bit light?
in this specific case, the subscriber is MQTT-FX. Okay, vNode is the publisher, and this is the subscriber. In this case, this MQTT-FX is connected all the time to the broker, right? It's connected all the time. So we are subscribed to this topic. So every time, so the broker knows we are subscribed to this topic. Every time the broker gets a new message under this topic, so the broker will distribute these messages to all the subscribers, of course, subscribe to this specific topic, right? Of course, in a broker, in a real broker, you can have all kind of securities saying, okay, this user has access to this topic or not, or can read, or well, can see the information, or there are many options for security in the brokers generally. Right now, I have no security, so I just subscribe and I'm getting this. But indeed, we are getting here messages every 5 seconds. Actually, I put myself, the frequency is in vNode. The frequency I'm sending messages is in vNode. I just put it in 5 seconds, but could be any other frequency. Is here actually, where is it? Here, is here. But of course, we can change this to any other frequency. And in this case, the subscriber is connected all the time. So there's an open socket to the broker. And then every time there's a new message, a subscriber is getting it.
Perfect. And just the last question before, as we are getting a bit long,
Of course.
licensing model of vNode. Can you please a little bit explain about licensing?
Yeah, okay, no problem. So all these, so the idea with vNode is that you have all these modules and you just use whatever you need in each specific project. So all the modules have no limits of how many connections, how many tags, how many devices, how many users, no limits. And what you license is the modules. So in one project, one computer, you install vNode, and in this in this vNode, you need to read from Siemens PLCs. So you just need to license the Siemens client. That's it. You don't need anything else. If one day you say, hey, you know what, apart from reading from Siemens, now I want to send data to SQL Server. So, okay, so now you need another module. It's called SQL Client, which allows everything that has been read by vNode to send it to SQL Server, MySQL, Postgres, and so on. So now you need another module, and you buy the license for this new module, and like this. So if you ever need another functionality, you just need to license that specific module. So you don't need to pay for a whole platform with a million functionalities you are not going to use. Also, the functionalities can be changed from one to another. Let's say one day you are sending data to SQL Server and your company decides that you're not going to work with SQL Server anymore. Now you want to send data to Azure. Okay, no problem. So you can switch this module to, which would be the SQL client. You can switch it to, for example, the MQTT client. So to send data to Azure, just as an example. Or one day you decide not to work with Siemens PLCs anymore, and now you want to read from Modbus. Okay, so you can switch. This module is the Siemens client. I want to switch it to Modbus client. Okay, no problem. You switch it, and that's it. So prices are all exactly the same for all these modules.
Great, Fabian. Perfect. Yes, that's pretty much it from our side, guys. So we will see our contact here in a minute. Fabian will share.
Let me go to this slide. So you can download actually vNode from our website. It's like free to download, and as you have seen, it's also free to test everything you need, and then decide what real modules you really need in each site, and each installation, each project. There are many to test, and some of them are going to be interesting, and some others are not. And thank you so much for attending
Perfect.
today.
Thank you so much, and we will share the email with you guys with the recording and with the presentation. And let's keep in contact. And
Any questions?
any
Please
question?
send me or
Awesome.
Abdul an email or give us a phone call. No
Yeah.
problem. So if we can help you with any of
With the
these three
POC
protocols.
or
Mhm.
yeah, with the POC or with any help you need, we can connect and we can help you with the POC or, for example, to start your digital transformation journey. Can you break down the licensing scheme? One other question, which can you break down the licensing scheme? One last question from Veronica. Can you please?
What do you mean with the licensing scheme? Sorry, I break down your license.
Veronica, can you please explain what do you mean by a licensing scheme?
I mean, each module has its own license. It's basically that. So you just license it's a key. It's just a text actually with a key that you put in vNode. So now these and these modules are running, and they will never stop. Once they have a production license, they will never stop. Unlike the demo licenses where they stop every 2 hours. This is the only difference. All right. We can talk
Okay.
about prices, of course, in private. We don't want to make this general webcast about product. We wanted to share information and knowledge about
Information. Yeah.
technologies, REST, MQTT, and of course, OPC UA, and share our experience comparing them. Of course, we can talk about prices in private, no problem. So thank you so much for coming today, okay? And whoever is interested, we can follow our private conversation, right?
Great.
This is going to be recorded, so you're going to get a link with the recording in case you want to reproduce this in your own environment. No problem at all. Also, no problem to help you to reproduce this in your own computers, right? Thank you so
Thank you so much.
much. See
Thank you
you
so
next
much,
time,
guys.
okay?
See you next time. Thank you, Fabian. Thank you,
Thank
everyone.
you,
Bye.
Abdul. Thank you, guys. Bye-bye.